One railway span collapsed, the tracks were torn apart, and a key supply route through occupied Crimea was suddenly out of service. In late June 2026, Ukrainian drones struck the railway bridge over the North Crimean Canal near Rozdolne. Kyiv said the attack damaged the rails and brought down part of the crossing. Satellite images taken on June 23rd later showed clear destruction at the site. But how did Ukrainian drones reach a fixed target deep inside Russian-controlled territory? One possible scenario is that a first wave forced Russian crews to activate radars, jammers, and short-range defenses. A second group may then have approached from another direction, using the confusion to strike the rail line and key structural points. This is a reconstruction, not a fully verified account. The more important development came afterward. When Russian repair equipment arrived, Ukraine's resistance network reportedly detected the activity. Another drone strike then hit the machinery and the damaged crossing, turning one attack into an effort to stop the route from being restored. If both the bridge and the team sent to repair it can be targeted, Moscow may need more fuel, manpower, time, and air defense to keep Crimea supplied. Stay with this story to see how one damaged bridge may have become a trap for the forces sent to repair it. Was Rozdolne only a broken crossing, or the beginning of a new phase in Ukraine's campaign to isolate Crimea? Rozdolne mattered because it was not simply another bridge on a local rail line. It sat on a transport route that supported movement inside occupied Crimea and linked the peninsula with Russian forces operating farther north in southern Ukraine. Fuel, ammunition, engineering equipment, and other heavy supplies depend on routes like this, because rail can move far more cargo than road convoys with fewer vehicles and less fuel. Ukraine had already shown interest in the area before the main strike. Several attacks were reported against the railway crossing over the North Crimean Canal and a nearby road bridge. That pattern suggested the objective was broader than damaging one structure. Kyiv appeared to be testing how much pressure could be placed on the transport network around Rozdolne, and how quickly Russia could restore movement after each disruption. According to Ukraine, the most serious attack came during the night of June 21st into June 22nd. The rails were damaged and one span of the railway bridge collapsed. That was important because even limited structural damage can force traffic to stop until engineers inspect the crossing. A railway bridge does not need to disappear completely to become useless. If the track shifts, the deck cracks, or the supports lose stability, sending a loaded military train across it becomes too dangerous. Satellite images taken on June 23rd showed clear changes at the site. They supported the claim that the crossing had suffered major physical damage, although public images could not reveal the exact condition of every support, rail section, or foundation. The military value of the route came from the way Russia used Crimea as both a base and a transit zone. Supplies entering the peninsula could be moved towards storage areas, airfields, ports, and units supporting operations in Kherson and Zaporizhia. The same network also allowed Moscow to shift cargo between different parts of Crimea without relying entirely on trucks. When one fixed crossing stopped working, planners had to change schedules, hold trains at other locations, or redirect cargo through a smaller number of available routes. That creates a second problem. Moving freight from rail to road is possible, but it is less efficient for heavy military loads. More trucks are needed, which means more drivers, more fuel, more maintenance, and more protection. Road convoys also create visible patterns. They gather near junctions, slow at checkpoints, and often use the same limited corridors, giving reconnaissance drones more opportunities to watch them. Ukraine, therefore, did not need to destroy the entire Crimean railway system. A more practical approach was to disable selected bridges and force Russia to make repeated adjustments. Each delay could affect the timing of ammunition deliveries, fuel movement, and troop rotation. One broken crossing might not stop a campaign, but several bottlenecks can make the whole network slower and harder to manage. Rozdolne became important for that reason. It showed how a fixed piece of infrastructure could influence a much wider battlefield. The damage did not isolate Crimea by itself. but it added pressure to a transport system already required to support military bases, civilian movement, and forces deployed beyond the peninsula. But to damage a bridge deep inside Russian-controlled territory, Ukraine first had to send enough drones through the layers of defense surrounding the target. The strike on Rozdolne was more likely to succeed if Ukraine used several waves of drones instead of sending every aircraft along the same route at the same time. The exact type of UAV has not been publicly confirmed, and that uncertainty should remain clear. FP2 is one possible candidate because it was designed for medium-range attacks against railway, logistics, and other fixed targets, but there is no firm evidence that this model was used at Rozdolne. A realistic scenario begins with a small group approaching first. Their purpose would not have to be simple sacrifice. They could force Russian crews to switch on radar, activate jammers, and prepare short-range air defense systems before the main strike group entered the area. That reaction would reveal how quickly the defense responded and which direction received the greatest attention. The main group could then arrive from a different bearing. Instead of following one narrow corridor, the drones might spread across several lines of approach, with enough distance between them to make tracking more difficult. This would force Russian operators to compare several moving targets, judge which ones carried the greatest threat, and decide where to direct missiles, guns, or electronic warfare first. Timing would be central to the plan. If the second wave appeared too early, every target could be handled as part of the same engagement. If it arrived too late, Russian crews could reload, reset their sensors, and focus on the new direction. The most effective gap would be long enough to draw defensive fire, but short enough to keep the system under pressure. The Ukrainian goal would not be to save every drone. Some aircraft could be lost to jamming, interceptor fire, or navigation error, while the mission would still succeed if a few reached the bridge. Against a fixed structure, even a limited number of heavy warheads can matter because the target cannot move, hide, or change position once the final approach begins. Those drones would likely aim at parts of the crossing that carried the greatest structural load. The rail deck, the connection between spans, the area nearest support, or the track leading onto the bridge could all be valuable targets. A direct hit on one section might not destroy the entire structure, but it could make the route unsafe for loaded trains and force engineers to stop traffic. Another advantage would come from keeping the formation loose. Widely separated aircraft reduce the chance that one burst of gunfire or one defensive response can defeat several targets together. They also make it harder for operators to predict where the next threat will appear. This is why the exact number of Ukrainian UAVs is less important than the effect of the few that may have broken through. A defense can destroy many incoming aircraft and still fail its main task if the surviving weapons disable the object it was assigned to protect. The result is measured not only by how many drones were intercepted, but by whether the bridge remained usable afterward. The attack also shows the value of uncertainty. Russian crews could not know with confidence which aircraft were decoys, which carried larger warheads, or whether another group was approaching from a different direction. Every target demanded attention, and every decision consumed seconds that could not be recovered once the drones entered the final stage. If Russian air defense stopped most of the incoming UAVs, but still failed to protect the bridge, should that be judged as a tactical success or a mission failure? The defense of Rozdolne would have depended on three functions working together without delay. Russia first needed to detect the incoming drones, then disrupt their guidance, and finally destroy any aircraft that continued toward the bridge. Systems such as Podlet, Pol-21, and Panzer fit those roles, but there is no public proof that all three were deployed at this exact location. The first layer would be early warning. A radar designed to watch low-altitude airspace could search for small aircraft flying close to the ground, where terrain and the curve of the Earth reduce detection range. The challenge is not simply seeing an object on a screen. Operators must decide whether it is a real threat, a false return, or part of a larger group still outside the protected zone. Once a target is identified, the information has to move through the command chain. Coordinates must reach the unit responsible for electronic warfare or short-range interception. Even a strong radar offers limited value if the warning arrives late, the track is lost, or several drones appear from different directions at once. The second layer would try to interfere with navigation and control. A system such as Pole 21 can disrupt satellite signals in a protected area, which may reduce the accuracy of drones that depend heavily on GPS. Yet jamming does not guarantee a kill. Some aircraft can continue on inertial guidance, follow a stored route, or use an optical sensor during the final approach. Electronic warfare also creates a difficult choice. Strong interference can affect enemy systems, but it may also complicate friendly communications or reduce the clarity of the wider air picture. Operators must decide when to activate the jammer and whether the incoming aircraft are already too close for signal disruption to change the result. The last layer would be a short-range air defense system such as Pantsir. Its task would be to destroy the drones that survive detection and jamming. Missiles offer reach, while automatic guns provide a final option at closer distance. However, the crew still faces limits in ammunition, tracking channels, reaction time, and the number of threats it can engage at once. A single drone is a manageable problem. Several aircraft arriving from separate bearings create a much harder situation. The radar must shift between tracks, the crew must rank targets by danger, and each launch takes time. A vehicle that appears to be a decoy may still carry a warhead, while the aircraft that looks less threatening may be aimed at a critical support. This creates the central weakness in defending a fixed structure. The bridge cannot move away from danger. Ukraine can adjust timing, altitude, route, and approach angle, while Russian crews must remain near the same object and prepare for many possible attack patterns. The air defense network does not need to collapse for the mission to fail. Radar may detect most threats, jammers may push several aircraft off course, and missiles may destroy others. Yet if even a small number reach the rail deck or a key connection point, the crossing may still become unsafe. That is the difference between an interception rate and actual protection. The first measures how many drones were stopped. The second asks whether the bridge continued to serve its military purpose after the attack. The first strike may have forced the crossing out of service, but Russia still had one urgent option left. It could bring in engineers and repair equipment as quickly as possible. The second phase at Rozdolne may have mattered more than the first because it targeted Russia's ability to recover, not only the bridge itself. After the railway crossing was damaged, Russian teams brought specialized equipment to the site so they could inspect the structure, clear debris, and begin restoring the line. Ukraine's Special Operations Forces said members of the resistance network inside occupied Crimea detected that activity and passed the information to the strike units. AP and the Polish Center for Eastern Studies also noted the two-stage pattern, although the full battlefield sequence could not be independently verified. Neither source confirmed the exact number of drones or the precise condition of each vehicle. What is clear is that the repair effort became part of the operation rather than the end of it. In a realistic reconstruction, Ukraine would not have needed to launch the second wave immediately. The more useful option would be to wait until the machinery was fully deployed and difficult to move. Railway repair vehicles often need stabilizers, lifting arms, cutting tools, and access to the damaged track. Once those systems are extended, the crew cannot simply drive away within seconds. That creates a narrow window of vulnerability. A drone arriving too early might hit an empty work site, while one arriving too late could find the repair already finished or the equipment moved undercover. The resistance network therefore becomes important because local observers can report when engines start, lights appear, cranes rise, and workers gather near the bridge. Ukraine did not need to destroy every vehicle at the scene. Damaging one rare machine, blocking the track with debris, or forcing the crews to leave could stop the work for hours or days. Specialized railway equipment is harder to replace than an ordinary truck, and moving another unit into Crimea takes time, planning, and protection. A second strike could also target the parts of the bridge that had already been weakened. Fresh repairs are often more exposed than the original structure because temporary supports, open rail sections, and newly placed materials remain visible. If another warhead hits the same area, it can undo recent work and deepen cracks that engineers were trying to control. The timing also places pressure on Russian security forces. They must protect the engineers, watch the sky, search for possible observers, and keep access roads open at the same time. Each task draws personnel away from the repair itself, which means even an unsuccessful warning can slow progress without causing another direct hit. The military effect is larger than the direct cost of the damaged machinery. Every delay keeps trains away from the crossing, holds cargo at other stations, and forces planners to use less efficient routes. It also creates fear among the crews sent back to the site because they know the area may still be watched. Russia then faces a difficult choice. It can rush the repair and accept greater risk, or it can slow the work, add more air defense, and search the surrounding area for observers. Both options consume resources that could be used elsewhere. This is the key change in the campaign. Ukraine was no longer attacking only concrete, steel, and rails. It was attacking the recovery process itself. The bridge became a continuing target, while every crane, truck, and engineering team sent to restore it could become part of the next strike. So which causes the greater military loss? Bringing down one railway span, or making sure Russia cannot repair it safely? Rozdolne was not an isolated strike. It formed part of a wider Ukrainian effort to make the movement of fuel, ammunition, equipment, and personnel across occupied Crimea slower, more expensive, and less predictable. Earlier in June, Ukrainian forces struck the Chonhar Bridge corridor more than once, showing a pattern of returning to the same route after Russia began adapting or restoring traffic. That pattern matters because a single damaged crossing rarely ends military transport. Russia can redirect vehicles, repair the road, move cargo onto another rail section, or increase the use of sea routes. Ukraine therefore appears to be attacking the network as a connected system rather than treating each bridge as a separate target. The goal is to create repeated interruptions, then watch where traffic is forced to move next. During July, pressure expanded beyond one railway line. Ukrainian operations targeted railway infrastructure, fuel storage, pumping sites, power facilities, air defense positions, and maritime transport linked to Crimea. These attacks placed several parts of the supply chain under pressure at the same time. A bridge carries the cargo, a fuel depot supports the vehicles, a power site keeps equipment working, and an air defense unit protects the entire process. Moscow still has several options. Cargo can be moved by road, sent through other rail sections, carried across the Kerch Bridge, or transferred by sea. Yet every change creates a new concentration point. Trucks gather near checkpoints and junctions. Trains wait at yards before entering a smaller number of usable corridors. Ships depend on ports, loading areas, and predictable coastal routes. These movements can be watched. Once traffic is redirected, reconnaissance drones, satellite images, resistance networks, and other intelligence sources may reveal which route is becoming more important. Ukraine can then decide whether to attack the new bottleneck, the vehicles using it, or the facilities needed to keep it operating. Russia can respond by placing more radar, electronic warfare, and short-range air defense near bridges, depots, and transport hubs. That may improve protection at one location, but it also creates a wider allocation problem. Every system moved to guard a railway crossing is unavailable somewhere else, including an airfield, fuel base, command site, or ammunition storage area. This does not mean Crimea can be cut off by one successful night of strikes. The peninsula is supported by several transport methods, and Russia has engineering units capable of restoring damaged infrastructure. Moscow can also spread cargo across smaller shipments, use temporary crossings, increase night movement, and place more security around repair work. The more realistic Ukrainian objective is pressure over time. Each delivery that arrives late may affect fuel reserves, maintenance schedules, or the timing of reinforcements. Every route that requires additional escort raises the cost of transport, while each damaged crossing forces planners to create a new timetable and protect both the old site and the alternative. The campaign therefore becomes a contest of endurance and adaptation. Ukraine must keep finding weak points, while Russia must defend a large network with limited radar coverage, interceptor missiles, engineering teams, and trained crews. Success will not be measured only by destroyed structures. It will also be seen in how much extra effort Moscow must spend to move the same amount of military cargo. Rozdolne showed that a bridge can be attacked, but its deeper lesson is more serious. Any route chosen to replace it, any depot used to support it, and any force sent to restore it may become the next part of the battle. The bridge at Rozdolne may be broken, but the larger battle over Crimea's supply network is only beginning. Ukraine's objective was not limited to damaging steel, concrete, and railway tracks. The deeper aim was to stop Russia from restoring the route quickly. The first strike hit the crossing, local resistance members then watched the repair effort, and another wave of drones reportedly attacked the equipment and the weakened structure. That sequence turned railway engineering into a direct part of the battlefield. Russia still has several choices. It can repair the damaged span, build a temporary crossing, move more cargo by road, or redirect supplies through other railways, the Kerch Bridge, and maritime routes. Yet every option requires more fuel, workers, protection, and planning. It may also create a new bottleneck that Ukrainian intelligence can monitor. The strategic effect will depend on whether Ukraine can continue striking repair sites, transport hubs, and replacement corridors faster than Russia can restore them. The next phase may therefore move beyond Rozdolne. Railway yards, bridges, road junctions, ports, and fuel facilities could become the new pressure points as Russia searches for safer ways to support its forces in southern Ukraine. Will Moscow protect the old route, or will it move traffic toward another corridor and create a new target? Share your view in the comments. Like and share this video to support clear military analysis. Subscribe to Military Force for more reports on the weapons, strategies, and political decisions shaping modern warfare.